Welcome to this step-by-step explainer. Today, we're uncovering the invisible boss that's literally running our modern digital world. Whether you're a total beginner trying to figure out how your devices actually tick, or a focused learner wanting to grasp the deeper logic behind everyday tech, well, you are in the exact right place. We're going to completely demystify the operating system and build a rock-solid mental model for you. Let's get into it.
But to really understand where we are today, we kind of have to look back at where we started. There's this famous quote attributed to Thomas J. Watson, the former chairman of IBM. He supposedly said, "I think there's a world market for maybe 5 computers." 5! Looking back, that prediction is wildly inaccurate, right? But it actually perfectly highlights just how exponentially computing has scaled up. We've gone from these massive, clunky, room-sized machines to having super powerful computers basically woven into the very fabric of our everyday lives. And at the heart of every single one of those computers, the thing making all that crazy complexity manageable is the operating system.
So here's our quick roadmap for today. First, we'll meet the boss, then we'll look at the hardware interface, explore 2 different views of the system, check out the OS in the wild, and finally wrap up with the big picture.
All right, let's jump right into Section 1. Meet the boss, the hardware interface.
Now, before we officially meet the manager of the computer, we first need to define exactly what it is they're actually managing, right? So, hardware refers to the tangible machine and its electronic components. We're talking about your main memory, your input-output devices, storage drives, and the central processing unit, or CPU. It's absolutely crucial here to separate the physical, tangible hardware, stuff you can physically touch, from the invisible software instructions that actually bring it all to life. You see, a computer system is really a partnership between these 2 elements, and the operating system, well, it's the chief piece of software entirely in charge of that partnership.
And this idea brilliantly illustrates our core analogy for today. The operating system acts as the vital interface between those tangible hardware components and you, the user. Basically, think of the OS as the ultimate boss. It controls every single file, every device, every tiny block of main memory, and every millisecond of processing time. It even controls exactly who can use the system and how. When you send a command, it's the operating system's sole job to make sure that command gets executed. Or if it can't be, it makes sure you get an error message explaining why. It is the absolute, undisputed manager of the whole shebang.
What's really fascinating here is how the operating system juggles all these different resources. It is heavily concerned with the allocation of resources and services. It literally has to distribute memory, processors, devices, and information and do it all super efficiently. The engineers who design these systems, they share a common goal: maximize the use of the system's resources while totally minimizing downtime. They have to factor in maximum and minimum RAM, the huge variety of devices connected, and strict security requirements just to keep the whole system running like a well-oiled machine.
Moving right along to Section 2, Core Concepts. 2 different views.
Because there are always 2 sides to every computing question, we really have to look at how different groups interact with this software boss. We can basically divide this up into the user view and the system view. So the user view is all about how everyday people, or well, more accurately, how the programs written for everyday people utilize the operating system. If you're writing a word processor or just using an email app, you fall right into this category. The system view, on the other hand, is completely focused on how the operating system gets under the hood and handles the actual nitty-gritty, low-level hardware logic.
So the really crucial takeaway here is that the operating system provides these incredible services to users and programmers so that we can actually use a computer without ever having to deal with the low-level, insanely difficult hardware commands. Think of the OS as a massive shield. Imagine if every single time you wanted to save a file, you had to manually write out a complex string of binary code to instruct the physical disk on exactly where and how to spin and how to store the magnetic data. You'd literally never get anything done. The OS steps in and provides a clean, super simple interface so you can just click save and move on with your life.
To truly grasp this invisible behind-the-scenes dynamic, let's just walk through a micro journey of something you probably do, hundreds of times a day. Simply moving your mouse. Step 1. The user moves the pointing device. Step 2. That physical movement instantly generates a hardware event known as an interrupt. Step 3. The operating system immediately steps in, pauses whatever else it was doing, and handles that interrupt to update the cursor position on your screen. This all happens so incredibly fast you don't even notice it, but that's the OS diligently managing that hardware translation every single millisecond.
Okay, let's pivot a bit. Section 3, Practical Application. OS in the wild.
Now, we're all pretty familiar with general-purpose systems, right? Things like Windows, Mac, or Linux on our laptops.
But the modern world actually relies heavily on something called an embedded system. This is highly efficient operating system software designed to perform very specific, non-interchangeable programs. These run on hardware with seriously limited resources. Think much slower CPUs and way smaller memory banks. To make this work, designers strip away any unneeded features, leaving only a tiny kernel, which is the core portion of the software, and then they often add in redundant safety features to ensure absolute, unquestionable reliability.
And because of that, there are some genuinely surprising places you'll find an operating system hiding in plain sight. Personal digital assistants? Sure, that makes sense. But cable TV controller boxes, electronic games, copiers, fax machines, remote controls, cellular telephones, and even digital cameras. Wait, really? Yes! Even your everyday cable box and that basic TV remote sitting on your couch require an embedded operating system to manage their internal hardware and interpret your button presses. It's kind of wild to think about.
Let's scale that up and see how this builds into something as critical as a car. Modern automobiles are essentially just rolling computer networks at this point. Embedded operating systems in your car are entirely responsible for critical tasks. We're talking engine performance, anti-lock braking systems, navigation, entertainment, and complex engine diagnostics. Here, the embedded software acts as the absolute boss, actively keeping you safe and on your road. Because the system resources in a car are limited and the real-world stakes are so incredibly high, these operating systems are highly specialized and relentlessly efficient.
All right, let's bring it all together. Section 4. Key takeaways, the big picture.
If you remember absolutely nothing else from this explainer, these are the 3 most important takeaways to lock in. Number 1, the operating system is the chief piece of software. It is the boss that controls every file, device, memory block, and processing moment. Number 2, its primary gift to all of us is acting as a shield, completely hiding those overwhelmingly complex hardware commands behind a clean, user-friendly interface. And number 3, it doesn't just live in your laptop. Highly specialized, embedded operating systems live everywhere, quietly running everything from your TV remote control to your car's braking system.
So, we've gone from Thomas J. Watson thinking the entire world only needed 5 computers to living in a reality where almost every physical object we interact with has a tiny software boss hidden inside it. As our everyday objects become embedded with even more complex and interconnected operating systems, you have to ask, what will the boss be managing for us tomorrow? I'm going to leave you with that provocative thought about the future of our embedded digital world to ponder. Thanks so much for joining me for this explainer, and keep learning.